In this repair video, we're going to be working on an Asus laptop, yet another Asus laptop that came in for no power. I have the laptop right here, and we already disassembled the motherboard. And the model number on this one, just for your information, is GL703V. And we have the motherboard right over here. It's a big one. A lot of components on the front, a lot of components on the back. Where should we start? Now, the first thing that we did was plug the charging cable, and the charging connector is the type that has a cable that connects to the connector on the board. So what we did was disconnect that cable. We plugged the charging cable, the charging adapter, and we measured voltage at the cable, at the positive and negative side of the cable, and we measured 19 volts. But as soon as we plugged the cable onto that connector, which is on the board, then we lost that voltage. The power adapter shut itself off because it detected a problem with the motherboard. So right now we know that we have a problem on the motherboard. First thing I want to do is look for the power MOSFETs. I do not see anything here. I do not see any MOSFETs here. And none here. We do have the V-Core MOSFETs down here. We have more MOSFETs here, but these are not the ones for power. Let's flip the board. And I do not see any MOSFETs. However, I do see two of them right here. So let's measure and see if we have a short at those MOSFETs. Maybe I can do this. We'll go under the microscope later, but I just want to show you the overall picture. Meter in diode mode, and we're going to measure at this point here. Do we have a short? And we have a short. If we measure here, we should not get a short. And the gate, no short. Drain, source, and gate on this chip, no short. The last Asus repair that we did on our channel, we found what's causing the short, and we ended up also replacing the MOSFET because the MOSFET was shorting out to itself, gate, source, and drain. So let me put the meter in continuity mode. I was measuring in continuity mode and not in diode mode, but that's okay. Let me measure in diode mode one more time. We should have a short here, and we do. Go back to continuity mode, and we're gonna measure drain to source. They're connected. So right now it looks like drain, source, and gate are connecting with each other. It's very likely that we have a bad MOSFET here, and of course we cannot test the functionality of this MOSFET until we get rid of this one. Right now our concern is what's causing the short. What we're going to do is inject 1 volt at the shorted area of the MOSFET, which is this one right here. And then under the thermal cam, we're going to monitor and see what's getting hot on the board. After we find what's causing the short, then we can replace that MOSFET, and we should be back in business. So let's grab our thermal cam, turn it on, and our voltage injection tool is currently at 1 volt. Let's go to our thermal cam. And we're going to monitor and see what's getting hot. So I'm going to inject voltage right over here. And right now I see a current draw of 4.38. A lot of current. No obvious heat spots. Inject voltage and flip the board. Look on the, yeah, right there, right there, right there. Something is getting hot on back of the board. We got it. Right now we injected voltage at the shorted area of the MOSFET, and something got hot right over here from the back. Right there. So we're gonna have to see what's in this area that could possibly cause a short. And I got it. I found it. Look at the cap. Look at that cap. Look at that beautiful, amazing cap. And the cap is out. That's it. The soldering is perfect. So the job is done here. Let's flip the board, and I want to go over those MOSFETs one more time. I want to see if we still have a short here. Meter in diode mode. And the short is gone. We are reading 0.447 voltage drop. 0.447 voltage drop. Amazing. Now I want to test to see if the first MOSFET is shorting to itself. Gate, drain, and source. So we're gonna measure this with this, this with this. Yeah, this MOSFET is gone. It's bad. We're gonna have to replace it. Flux helps with the flow of solder. We do not need flux to desolder a component, but it just helps with the flow of solder. And that's enough. Now let's solder that shit back on. Right now, meter in continuity mode, and we're gonna test drain to source. No short. To gate. To gate. Nothing. Very good. We got rid of the short. We replaced the faulty MOSFET. And I'm gonna give this to Big Boss to reassemble and test, and I'll be back. I'm back with the laptop. And we have good news and bad news. The good news is we did make progress, and the bad news is we still have issues. Let me show you what I mean. We're gonna plug the charging cable. And when we plug the charging cable, we do see the charging light, the amber light right here. And that's a very good thing. Now, if we try to power the laptop on, and I do not have the hinges screwed in yet, but if we power the laptop on, look at this. We see the lights, the colored lights, awesome, amazing. The fans usually spin, but then what happens is the computer shuts back off, like this. I had the fans connected and the heatsink connected, same issue. The computer is shutting itself off as soon as the fan spins. So what's causing this? The fan is spinning for 1 second and then the computer shuts off. We have to look at the area that we worked on. Likely the capacitor area, because that capacitor was blown. It may have caused something else to blow next to it. Likely a MOSFET, but we're gonna have to check. Gate is not shorting to source, it's not shorting to drain. Same thing goes here. And we're all good here. Nothing to worry about. Nothing to worry about. Let's flip the board and go to the capacitor area and just do some measurements. So right here, if you recall, we replaced this capacitor. Meter in diode mode. Let's test for a short. We should not have a short here. Okay, we are getting a voltage drop of 0.39, and that's perfect. However, this capacitor connects with this MOSFET, right? Let's measure drain to source. Let's measure gate to either drain or source. And I think we should be good here. What if we do the same here? And I think we should be good. What if we measure this resistor in resistance mode? What do we get? 2.6 ohms. That's fine. I mean, right now meter in diode mode, and it looks like we have a short. Again, we have a short. What's going on? Why do we have a short? Now we do not have a short. I don't know. MOSFETs are not testing bad. What else could be the problem? What else could be the problem? I mean, right now, honestly, I do not see anything obvious with those MOSFETs, but what if the problem is, in fact, one of those MOSFETs? I can't think of anything else. Maybe we should replace the MOSFETs and see what happens. Right now, I have no clue what's causing the computer to power on and then back off. But since this was the problematic area, we have to focus here. Now we're going to use a donor board. The combination of those two MOSFETs are popular on many boards. We should be able to locate some here and right there. And let's grab the other one. Fume extractor off and not the light. Big boss already left for the day. Otherwise I would have given this to Big Boss and he would have assembled it in 30 seconds. I have all the cables connected and all we have to do is try to power it on and see if the laptop will stay on. Power cable connected, and let's see. We do see the lights on the keyboard, but will it stay on? That's the question. Will we see anything on the screen? It doesn't look like it. It went back off. I do not know what's causing this, but I'm gonna call it off for today and maybe we can work on this again tomorrow. I may honestly never be able to figure out the problem, but I'm gonna give it a second attempt tomorrow and we'll see what happens. That's it. I hope you enjoyed this video, even though it's a no fix. Don't forget to like and subscribe, and we'll do something else in the next video.